3G already?
No. The boxes, the BTSs that are in use in this installation today here at the Congress are 2.75G if you want to use that vocabulary. So they support GSM, GPRS, and Edge, but nothing beyond that. There are 3G models, and of course everyone knows they're femtocells, and we also have, well, did some research on various femtocell models already. They're relatively nice devices for 3G. However, the big issue is that there are a lot of tools missing for open source developers. 3G is implemented almost entirely in ASN1 packed encoding rules, PER, not related with DER and BER and all the stuff that people are familiar with. And apart from an Erlang module, there is no implementation of those encoding rules for ASN1. So the very fundamental tools to play with 3G protocols are missing today.
Okay.
So anyone who is an expert on ASN1 and maybe on even on packed encoding rules, please do something. Help us out.
What do you think are the chances to, for example, take a very old phone? Maybe you take an old Mercedes or BMW with the first generation built-in telephone that was very big, and then say, okay, we want to make a man-in-the-middle attack. So you book in with the phone into the network and have your own BTS maybe somewhere in a shielded room, and then you sit with your phone, call into your BTS, and the BTS goes to the phone of the car, and the car goes to the network.
Yeah, that is a typical man-in-the-middle effort. The question is how accurate do you want to have it? The problem, I mean, of course you can just have a BTS here and a phone here and then connect the audio somehow.
No, that's fake. There should be real. So that it feels like being maybe in O2. So I am sitting in my basement and I use O2 in the frequency of 900 megahertz, for example.
Yeah, the problem here is that you need a phone where you can access the lower levels of the protocol again. That's the issue, right? So for the network side, we now have open source protocol implementations that we can get at all the layers we need, but on the phone we cannot. So in order to sort of be a real man in the middle, even for authentication and all these bits in the GSM network, then we need access to the layer 2 messages on a mobile phone, and that is something that which we don't have in any of the phones.
So, but if you, for example, find a very old phone that was filled with tons of DSPs, like the BS11 was filled with lots of devices, and so if you find a big old car phone that is quite bulky, maybe you find a place where you can solder and get the signals.
It might be possible, yes. I personally would not want to go that way, since yes, you can implement it for yourself, but it will be very hard to reproduce for anyone else, because those phones are very few and it's limited to GSM 900. And I mean, as I said, there are projects working on this, and we hope we will have something by next year, by the end of next year. But then we actually want something like a complete open source implementation of a phone, like OpenBSC, but the other way.
Okay. Is there a project that is doing quite well in this way?
Well, Dieter and me are working on something, but it's very early stage, so I don't want to talk too much about it.
So, but would it be possible to take some FPGAs and software-defined radio and do something this way?
Of course. I mean, as OpenBSC shows, you can take the USRP software-defined radio, you can attach it to a PC, and you can run the network side of GSM. And of course, if you can do that, you can, I mean, there's no limitation why you should not be able to do the same for the phone side. It's just a question of doing it.
Yeah. Okay. Okay, thank you.
Yeah, welcome. Question over there?
My question, I think, was already answered just now. I wanted to ask if you plan to make a phone with an open source, with an open GSM implementation. So, like the OpenMoco you worked on, but the one that you can see actually what the GSM part of it is doing, which is not a closed GSM part, but something you can see what's happening.
Well, I'm not really interested in building actual phones. I'm interested in building a phone-side protocol stack and some like development board or something for that, yes. And with some luck, I will be able to have, I will have sufficient time during next year to be able to present something of that sort next year at the 27th C3. But it will not be a phone form factor or an end-user usable device or anything like that. It will just be something like, as I said, you can say, well, OpenBSC for the phone side or something, yeah.
And would that be usable in any normal network? For example, do you have to be certified in some way to use this to connect it to some carrier's network, or?
Technically, of course not. Legally, you might, but I'm not aware actually that. I don't know how it works in detail. I mean, regarding certification, there are multiple aspects. One of them is regulatory approval. So the approval that you can operate this equipment within the European Union or the United States or wherever you might be. That is something you can obtain. It's a matter of some level of cost. It's a low 5-digit sum that needs to be spent, but you can do it. And if you look at products like ISDN for Linux in the past, they have done it. It's an open source ISDN protocol stack implementation, and in order to attach it to Germany's network some 10 years ago or even more, you require to have a license. And the ISDN for Linux guys did that. They did the conformance testing, obtained the license, and there was an open source ISDN protocol stack that you were officially permitted to attach to the public network.
Just a quick interjection, sorry. Didn't the GSM spec say something about should not with regard to making things inaccessible to the user? Is this obfuscation not some part of the GSM spec?
No, I've never read anything like that. There are some things that are required by the spec. So for example, every phone is required to have a way to show you that the current radio channel is not encrypted. But at the same time, there is a requirement that the SIM card that the operator issues can override that setting and can prevent the phone from displaying that the call is not encrypted. Those are in the spec, but to the best of my knowledge, those are not, like, the compliance, the radio conformance testing is being done by the regulatory, as required by the regulatory authorities, and they don't care about that. They care about spectral purity of your signal, that you don't interfere with other radio equipment. That's the kind of requirements. In the United States, I know there is a specific test that a phone manufacturer has to pass, which the operators put on the mobile phone manufacturers if they want to sell their phone through that operator. But if you don't have such an interest, I don't think there is a reason. Of course, the network operators could come up with, well, if you buy that SIM card from us, you certify that you will only use a phone that has officially received permission from us to be used on our network. But I've never seen anything like that in terms of services or any thing. And to be honest, I believe that a lot of the cheap Chinese phones that GSM phones that you can buy today and that you can just put your SIM card in and use in any country of the world, I doubt that they have ever applied for the regulatory approval or any of these permissions. So that's already happening. And that's the reason why we have duplicate IMEIs or phones that don't have IMEIs at all and all these things. So I think there's very little that can be done. I mean, yes, you can put it in a contract and say it's illegal, but that's sort of all you can do from an operator point of view.
Thank you.
And then, I mean, you as the manufacturer of such an open source device, you could then try to use competition regulations. Say, this is anti-competitive. Why can my phone not be used? And I'm not sure how that will turn out.
Well. Apparently, there's still a lot to develop in the world of mobile networks and telephones. Harald opened a whole new world for me, maybe for you too. How did you like this lecture? Yeah?
And
we'd like to see this back. On our website, you can give feedback on this lecture. If you go to the schedule and you click on the OpenBSC presentation, then you can give your feedback. So please do that.